Hello, my name is Jaxon Coward, and this is our senior design project, the Artemis observation system. The other members of our team are Saahil Barai, Gabrielle Williams, Zohan Marediya, Erick Cortez-Valdez, and Dillon Heinen. We've all seen the catastrophic effects of wildfires and the damage they do to habitats and infrastructure, not to mention loss of life. By utilizing LoRaWAN technology, a long-range mesh communication system, we can help firefighters tackle these disasters more effectively and perhaps even stop them in their infancy. LoRaWAN is short for Long Range Wide Area Network. It's a type of communication protocol that uses open source technology and transmits over a far longer range than Wi-Fi or Bluetooth connections, making it valuable for applications in remote areas where cellular networks have poor coverage. Our system consists of a mesh network of nodes containing sensors that can measure both the presence and likelihood of fire. These sensors connect to a gateway a few miles away via LoRaWAN. When the gateway receives data from any one node, this data is sent through the internet to our website, where users can track the conditions at each node, as well as view the likelihood of a fire based on predictive indexes. Now I'll pass you off to Dillon, who will talk about the hardware on the node we designed.
Here we have the hardware for the Artemis observation system. In a typical setup, you'll have about 100 of these in the forest, monitoring different angles and positions. The device is based around a PCB that contains a PyCom microcontroller. This will be the brains of the device. It also has a humidity sensor, a temperature sensor, a carbon monoxide sensor, and a thermal imaging sensor. These will all be collecting data. That data will then be compiled by the PyCom and sent as a transmission packet. This transmission packet will be sent over LoRaWAN. There is a LoRaWAN module on the PyCom device, and then it'll be sent out the antenna that we have up here. And that will arrive at the front end, basically through the LoRaWAN gateway, and then it will be processed and displayed in a more attractive format. Now, additionally, on this device we have a recharge circuit. This is a 3.7 volt battery in the back in blue, and overhead we have the actual recharge circuit itself, and this can basically take as input a USB device or a barrel connector. Either will work, and the device can then be charged at your convenience or even charged on site. Alright, and then finally we have a reset button on the side that allows you to power cycle the device in its totality. It basically resets everything and restarts the transmission routine. Alright, next we'll move on to the actual front end itself.
Now for a demo of the front end of the Artemis observation system. I will start by showing you the front end web application and then demo the functionality of the software stack. As you can see here, there's a home screen with a short slogan, and then there are three main pages. The second main page is the About Us page, which details our objective and the team breakups. And finally, the map page, which contains the core functionality of the front-end application. The map displays all active nodes and information associated with each node in a pop-up box. Now for the entire software stack. We have the gateway software, which is managed by the Things Network. And we have AWS DynamoDB, which persists all our node data in a database so that it can be retrieved later to run analysis or to view old data. So to demo the function of our system, I will be simulating messages as if the node were sending them to the gateway. In order to do that, we will tap into one of the nodes we already have configured and send pre-configured test cases. So going to our test case document, we see that this payload corresponds to a JSON packet with these fields. Now I will simulate this uplink as if the node were sending it, and we should be able to see the message in our DynamoDB table. Now our item count has gone up to 14, and we see that the latest message corresponds to our last test case taken from the document. And on the front end, we see that there is an extreme likelihood of a fire based on the temperature, CO, humidity, and the MacArthur Index algorithm. I can take you through another test case to further exemplify the functionality. We will now simulate an uplink with a different characteristic of data. We now have 15 items in our AWS DynamoDB table, with our most recent transmission being shown at the bottom. And reflected in our front end, where the MacArthur Index now signifies a low likelihood of a fire.